What is a function? In simple words, a function is a special relation. It produces new elements out of some given elements. Let's understand it in terms of sets. In mathematics, a function is a relation from set A to set B if every element in set A has one and only one image in set B. This means that every element in set A is mapped to some element in set B. Note that no element in set A should be left out. Yes, we need an example to understand it better. We know that a relation from set A to set B gives us ordered pairs of the form A, B. Now let's look at the two sets A and B. Set A has elements 2 and 4 and set B has elements 10 and 20. Let's look at an arrow diagram to represent the relation B is equal to 5A. This is how we can write it in the set builder form. We know that 2 times 5 is 10 and 4 times 5 is 20. Hence the two arrows like this. We see that both elements 2 and 4 are mapped. Also, each of the elements in set A has only one image in set B. 2 has an image in 10 and 4 has an image in 20. So we can say that every element in set A is mapped and has one and only one image in set B. We can say that this relation from set A to set B is a function. Now let's look at set A and B again. Set A has elements 2 and 4. Set B has elements 10 and 20. Now we look at the relation B is a multiple of A from set A to set B. This is how we can write it in the set builder form. And here's the arrow diagram for the relation. Both 10 and 20 are multiples of 2 and 20 is a multiple of 4. Would this relation qualify as a function? Look closely at element 2 in set A. It has not one but 2 images 10 and 20 in set B. Element 4, however, has only one image. Since one of the elements has more than one image, we can say that this relation is not a function. Now let's introduce another element 9 to set A. So set A has elements 2, 4 and 9. Set B has elements 10 and 20. We want to know whether the relation B is equal to 5A from set A to set B is a function or not. Can you draw the arrow diagram for this relation first? Yes, this is how it will look. We can see that 2 is mapped to 10, 4 is mapped to 20 and 9 is not mapped to any element. So we can say that 9 has no image in set B. Although the elements 2 and 4 in set A have one and only one image in set B, every element in set A is not mapped. And hence we can say that this relation is not a function from set A to set B. Let's try out one last combination. Let us introduce element 35 to set B and remove element 9 from set A. So A has elements 2 and 4, set B has elements 10, 20 and 35. Is the relation B is equal to 5A from set A to B a function? What does the arrow diagram tell us? It says both elements 2 and 4 are mapped to only one element each, 10 and 20 respectively. No element in set A is left out. But there is something interesting we noticed here. Element 35 in set B is not an image of any element in set A. Is this relation a function? Yes, this relation is a function. This is because every element in set B need not be an image of an element in set A. The only condition for the relation to be a function is that every element in set A has one and only one image in set B. These were some examples to identify if a relation can be a function. So we can say that every function is a relation, but a relation may or may not be a function.